textbook?
I have pencils, but they're not sharpened.
Yay. Look, there's a Makinao Kutoria back there. All right, lesson 35. Why is your textbook still not open? This is like the 4th or 5th time that I'm asking. All right, so we've been talking about finding the greatest common factor of terms. Greatest common factor. Somebody give me a quick recap what we need.
The greatest factor between two numbers. That is multiplied by that number to get a bigger number.
Yeah, well, they don't necessarily have to be numbers. It could be algebraic terms, so involving a numerical coefficient and then some variables. This is the biggest thing that we can divide 2 or more terms all by. The biggest factor that they share in common. So factor that they share in common. So last week or whatever, we practiced doing things like this. So imagine we have a cubed x squared m squared plus a squared x m cubed minus a to the 4th x cubed a to the 4th x cubed m squared. What's the greatest common factor of these 3 terms? What's the greatest common factor of these 3?
A.
Nope.
It's not A, it's X.
Nope.
Wait a minute.
What's the greatest common factor? The biggest thing that we can divide all 3 of these by?
AXM.
No.
A2x.
Let's not say just a number for power. So you can say a squared or a to the 2.
You're late.
So a squared, then what? Then what? Good morning. Please give me 15 push-ups. A squared, what else? Not just a squared.
M squared.
What else?
M squared.
Yeah, and what else?
M squared.
And what else?
X squared.
No.
No, X.
X, yeah. A squared, x, m squared. All right, yes. A squared, x. Well, I'm just going in the same order that they're written in up there. Please, full extension at the top. Arms should be straight at the top.
What do you mean? Wait, I'm doing push-ups like Isaiah's doing push-ups?
No, you're not extending your arms all the way. Your body is staying nice and straight, but your arms, yeah, you should come all the way up at the top.
Oh, sorry.
All right.
Oh.
I like how low you get. Yes, that's. Well, make sure your elbows should be locked at the top. Yeah, like that. All right, so a squared, we can divide them all by a, not just a, but a squared. We can divide them all by x, not just x. Well, yes, just x, because this guy just has x, and m squared. Now, there's something else that we can do here. In addition to finding the greatest common factor, since this is a factor of all 3 of these, that means that we can divide it out of each of these terms. Yes?
Yes.
What's going to happen when we divide a squared x m squared out of each of these terms? What are we going to get? What are we going to get when we divide a squared x m squared out of that first term?
What A next A X M.
M squared divided by m squared.
Oh, there's nothing.
Yeah, okay, so we get ax and what is?
A squared X squared.
Right. If we divide our greatest common factor out of each of these terms, this is what we'll get. Everyone following so far?
I'm just subtraction by exponents.
What? Yes or no?
I don't get that.
Okay, so we found the greatest common factor. Yes? Then we divided each of these terms by the greatest common factor. Because the greatest common factor is the biggest thing that we can divide each of them by. So we divide a cubed x squared m squared by this. A cubed divided by a squared gives us a, x squared divided by x gives us x, m squared divided by m squared just gives us nothing. It's 1. Similarly here, a squared divided out, x divided out, m cubed divided by m squared leaves us with just m. And then with this one, a to the 4th, we're left with a squared, x cubed, we're left with x squared, and m squared divides out.
Is it dividing it or just subtracting.
We're not subtracting, we're dividing.
Okay, what, you literally just went from x to x, you went x to x3 and it's 2.
Okay, well, let's not say x3, let's say x cubed or x to the third power.
X to the third power.
And then we divided it by x.
Yeah. And we got 2. Let's subtract.
No, I got x squared. I didn't get 2, I got x squared.
X squared.
Right, remember when we multiply, what would happen if we multiplied x squared times x? What do we do to the exponents if the bases are the same? We add them, so that will give us x cubed.
Oh yeah, I know, so I'm saying, yeah, we added it and then it should be subtracting.
We're adding the exponents. We're not adding, we're adding the exponents. It's a form of multiplication. So when we're dividing, we subtract the exponents. X cubed divided by x to the 1 is x squared. We can think of it like this. We've got x times x divided by x, or actually even better is we write it like this. We've got x times x divided by x, right? X cubed divided by x to the first. These guys cancel out. We're left with x squared over 1, or just x squared. Okay, so when we're dividing things with exponents, we'll end up subtracting the exponents there. Okay, so this is what happens when we divide a squared x m squared out of each of them. What that means is we can rewrite this original thing that we had like this. What did I just do here? Notice we had divided a squared x m squared out of each of these. So if I write it like this, then I'm undoing that. It's the same, these are the same. They're equal to each other, right? How can we prove that they're equal to each other? Let's undo what we just did. Well, what is this? You look at this, you see this, what does it make you want to do?
Distribute. No.
Distribute, right. Okay, so let's distribute. So let's distribute here. What are we going to get?
A cubed.
A cubed,
X
Squared.
x squared,
X squared.
okay, plus what?
And
X
x to the
or
x
X
cubed
cubed.
and m squared.
This is how we undo distribution. Sometimes it's going to be more convenient to have things in a format like this. But sometimes it's more convenient to undo distribution. We could take this, we could distribute it out. We could also take this and go back to this. You see how I did that? We went from this, we got back to this, because distribution, remember, means we're going to multiply each thing by the same factor. So if we start with this and we want to go backwards, we ask ourselves, what's the biggest factor that we can divide out of each of those? How could we extract it from there? So we find our greatest common factor, then we divide each one by the greatest common factor. This is how we undo the distributive property. Does that make sense?
Mm-hmm.
Let's do another one. Let's do a simpler one. 2ax plus 2ac. What's the greatest common factor of these two terms? 2a is the GCF. Okay, GCF is 2a. So how am I going to rewrite? What else?
1x plus 1c.
No. Okay, 2ax plus 2ac is not equal to x plus c.
Oh yeah.
You can't just get rid of this. We have to convert it to something else.
A squared.
What? Okay, look at what we did here. We found our greatest common factor. We divided it out of each term, and then how do we write it?
Oh, it's distributed property.
Right, like it's something that we do the distributive property to. So how should I write this?
2a parentheses x plus c.
Yes, like that. What this means is that you take 2a and you multiply each of these things in there by it. Right, that's what we did. We divided it out, so this means multiply back in. And we can check our work by doing the distributive property to it. 2a times x, 2ax, okay, plus 2ac. Look at that. That's the same thing that we started with.
Mhm.
Yeah.
Hey, what are you doing?
Not really.
No.
It's almost gone.
We should be able to go in both directions. That's what we're doing here. Why? Because sometimes this format is more convenient and sometimes this one is more convenient. Understood so far?
Yes.
You guys understand this process?
Yes.
Undoing the distributed property? Okay, let's see a situation where this comes in handy.
So wait, what's for homework tonight?
You'll find out in a minute. All right, so let's find out a situation where this can come in handy. Say we have this equation. We want to solve it. We want to find a solution, find a root for this equation, find a value of the variable that makes this true. What are we going to do? How did you get that?
4 times.
Right, we divide both sides by 4. Okay, divide by 4 over here, divide by 4 over here. X equals 5. Great. What if we've got something like this? Can we simplify that?
Yes, you can.
How?
Cross over 4.
Cross out the 4s? So let's try with the numbers. So 2 plus 4 over 4, it should give us 2. So 2 plus 4 is 6 over 4. That did, yeah, that gave us 1.5. It should have given us 2 because we plugged in 2 for our variable here. So something went wrong.
Wait,
Something went wrong.
can you change the fours? Just turn them up into 1?
No, that's what we tried to do here. We tried to, oh, you mean like x plus 1 over 1?
Yeah.
Well, let's try that. 2 plus 1 over 1. No, sorry. So this on the left, 2 plus 4, we're plugging in 2 here, over 4 equals 2 plus 1 over 1. 2 plus 4 is what? Okay, 6 over 4 is equal to 3 over 1. 1 1/2 equals 3?
No.
No,
No, that's not correct.
that doesn't work either. Okay, why are these things not working? Why are these things not working?
We're not small.
When we have something like this, x plus 4 over 4, remember that the line of our fraction counts as a symbol of inclusion. We can rewrite this like this, x plus 4 divided by 4. Or x plus 4 times 1/4. Yes? You guys see how that works? Instead of dividing by something, we're multiplying by the reciprocal.
Yeah.
This dividing by 4 applies to both the x and the 4. You cannot undo a subtraction with division. You can't do that. Because that dividing by 4 has to happen to both terms. We can only use that dividing by 4 to cancel out. Yes? But over here, that doesn't work. What if we've got this? Can we simplify this? 4 parenthesis x plus 1, close parenthesis, over 4. Can we simplify that?
Mm-hmm.
What can we simplify this to?
4x plus 1.
What can we simplify it to?
4x plus 4 over.
And then
4x plus 4 over 4?
no.
Okay, that's less simple. We want to get it simpler.
No, that's
Can we make it easier than this? Is there something we can do to make this less complicated?
Bring it up.
Remember, This up here means 4 times x plus 1.
Yeah, so yeah, you can divide four.
Right, here we can divide out this 4. Because up here, we're taking this and multiplying by 4. And down here, we're dividing by 4. These can cancel each other out. Because here, notice, what's connecting this 4 to the x plus 1? What's connecting this 4 to the x plus 1? What operation? Multiplication. So can we undo multiplication with division? Yes. That's, in fact, the only thing we can undo multiplication with. Up here, what was connecting that 4 to the x? What's connecting it to the x? What operation is that? Addition. Can we undo addition with division? No. Okay. What about this guy? 3 times x minus 2 over x minus 2. How can we simplify this?
Divide x minus 2 and x minus 2.
Right. Up here, we're taking 3, we're multiplying it by this thing x minus 2. Then we're dividing it by this thing x minus 2, right? This is 3 times x minus 2 divided by x minus 2. So these two will cancel each other out. Yes?
Yeah.
Everybody following so far? Okay. Now, why does greatest common factors come in handy for this? Let's say we've got a problem like this. 3p plus 3 over 3. How can we simplify this? Can we make it simpler? Like if you hit the answers, yes, we can. We can simplify it.
Oh, no, I don't think so. Oh, yeah.
I think we can.
Divide 3 and 3.
Divide 3 and 3.
3p.
Remember,
So do both sides.
we can't, these two are connected to each other with addition. We can't undo division. We're not allowed to because it doesn't work that way. We're not allowed to undo addition or subtraction with division. How could we rewrite this to be able to simplify it? Let's take what we were doing before with finding the greatest common factor and apply it to this. So up top here, 3p plus 3. What's the greatest common factor of those two terms? 3. What do we get when we divide 3 out of each of those terms? P.
And one.
So, and what's connecting them? Yeah, p plus 1. These are the same, aren't they? 3p plus 3 and 3 times p plus 1?
Yes.
Those are the same, because if we distributed this, we get 3p plus 3. Okay.
Okay, now.
Is it clear now what we can do to simplify this?
Yes.
What can we do to simplify it?
Divide by 3.
The 3's cancel out, because here we're taking p plus 1 and we're multiplying by 3, and then we're dividing by 3. So here, these can cancel out, and we end up with p plus 1 in a simpler format. When you have a fraction or some kind of division, and one of the things has some addition or subtraction going on, you can often factor something out which will allow you to simplify it. Let's try this one. In case you want to look in the book, I'm doing the examples on 143. So this is the last example on 143, the very bottom. 3x, I'm going to do it on the right here. (3x minus 9x squared) over 3x. Now, right now, there's nothing we can do to simplify, because up here, our terms are connected with subtraction, and then we have division happening to them, and we can't undo subtraction with division. But is there another way we can write some part of this expression so that we can simplify it? Yes?
3x.
3x
Yeah, parentheses. Maybe, 3x. I'm sorry, negative.
X.
Negative.
What happens when, so 3x, you're correct, is our greatest common factor, because we can divide both 3 and 9 by 3, we can divide both x and x squared by x. What happens when we divide 3x out of 3x? What do we get? 3x divided by 3x gives us?
1.
Gives us 1. Anything divided by itself gives us 1. 3x. We're taking each of these terms and we're dividing 3x out of them. So 3x divided by 3x gives us 1. What about negative 9x squared divided by 3x?
Minus
Wait,
3x.
Mr. O. Won't 3x minus, 3x divided by 3x give us 1x to the negative 1?
No, because we've got 3x.
And isn't like every time x, y is down, there's a 1, right? And then you subtract it.
Right, so 3 divided by 3 gives us 1. What's x to the 1? So x to the 1 divided by x to the 1, so we subtract. 1 minus 1 gives us what?
0.
X to the 0. What's x to the 0 equal to?
Oh, 1.
1. So it's 1 times 1,
Oh,
or 1.
I thought you would add like 1 plus 1.
No, because we're dividing. When we divide, we subtract the exponents. Okay, so we got up top 3x times 1 minus 3x. On the bottom we have 3x. Now what can we do to simplify this?
Divide by 3x.
Right, up here we're multiplying by 3x, down here we're dividing by 3x. So an easier way to write this is 1 minus 3x. I would much rather calculate values of 1 minus 3x than 3x minus 9x squared over 3x. Wouldn't you? For one thing, this has some exponents involved. I mean, they're fine. They're just not. It's not like the decimals or anything, which I hate. But having to calculate out exponents by hand is obnoxious. Okay, let's do one more example, and then I'll set you guys free.
But how is it gonna be on the definition?
All right, we've got 5x. This is on page 144 if you want to follow along. 5x minus 25x squared over 5xy. Right now, we cannot simplify because we can't use this division of 5xy to undo the subtraction up top. So, what can we do to rewrite this in a way that will let us simplify it? How can we rewrite it?
Take out, you gotta get rid of like terms.
Where do we have like terms?
5x and 5x.
It's gonna be the same.
Okay, 5x and 5xy are not like terms. They have to have all the same variables. This guy is 5x, this guy's 5xy. And besides, we can't do anything between this 5x and this 5xy. Because right now this 5x is something connected to it by subtraction, and it's connected to, they're both connected to this by division. So we can't,
It's gonna be like
not gonna work.
5x.
What is?
Like when we do it, like
Yep.
5x, principal 1 minus 5x.
Notice how he did that? Up top, he factored out the greatest common factor. He says 5 and 25. The greatest common factor of those two is 5, because we can divide 5 by 5, and we can divide 25 by 5. X and x squared, the greatest common factor is x. So our greatest common factor is 5x. Okay. Then what happens when we divide each of these by 5x? 5x divided by 5x gives us 1. 25x squared divided by 5x. 25 divided by 5 gives us 5. X squared divided by x gives us x. And then still over what? 5xy. Now what can we do?
Divide 5x 1. On both sides, and then you'll have like 1 minus 5x
Over what?
1.
Right. So notice, this is 5 times x times 1 minus 5x. On the bottom we have 5 times x times y. Multiply by 5 up here, divide by 5 down there, they can cancel out. Multiply by x up here, divide by x down here, those can cancel out. That y, can we simplify out that y? There's nothing to cancel it. So we're left with 1 minus 5x over y. That's still a lot easier, a heck of a lot easier to deal with than this annoying guy over here. But we still have that y on the bottom. So you won't necessarily be able to cancel out everything on the top and the bottom. Questions, comments, concerns? All right, for the weekend, and you've got about 20 minutes, over 20 minutes now to start it. 35, same deal, all except 3 and 4.
Question.
Yes?
I think I'll find out while moving.
No.
What?